A very good morning to all of you. So today we'll be discussing transform coding. In transform coding, here we see in the previous slide, the input image coefficients are directly given to the encoder. Input image coefficients are directly given to the encoder. Uh, so this is, we can say, is a special domain operations in transform coding. Whereas in this is directly given to the encoder. So this is we can say is a spatial domain operations. Whereas in transform coding, what is happening in transform coding? What do we do? We perform a reversible linear transform on the image coefficients, and then the transform coefficients are quantized and coded. So uh, this is how we achieve the compression in the transform coding. So what do? We take an image, perform some transformations, on it. It can be a Fourier transform, it can be a wavelet transform, or any other transform. We get the transform coefficients, and from transform coefficients, we perform quantization. And the quantized coefficients, here we get the quantized coefficients, will be coded. So, this is the process we are following for transform coding. So how do we achieve compression and decompression transform coding? Let's have a look. We have an input image n cross n dimensions. You can see we have an input image of n cross n dimension. That image is divided into sub images. So this will be divided into n cross n sub images. The dimension will be n cross n sub images, and then on every sub image, what do? We perform transform on that image. This transformation for natural image this transformation for natural image, several coefficients of the transformation will be very small, then coefficients can be discarded, or those coefficients can be partly quantized by using this. So quantizer. So by doing so, we will be able to achieve a good compression without losing much of information. So the work of Fourier transform, what will the work of Fourier transform is to calculate the image pixel values, and then by doing this, what do? We remove the interpixel redundancy, and then the output of Fourier transform, that is transform coefficient, that will be given to the quantizer. And the quantizer will quantize will partly quantize small coefficients. So these small coefficients will not contain much information. So what we want to say, that these whatever the small coefficients we will be getting after quantization, those coefficients will not be containing much information in the forward transform coefficients. So those coefficients will be discarded. By doing so, we will be able to reduce the psychovisual redundancy. And the output of this quantizer will be given to the symbol coder. You can see the symbol coder in the image. So output of this quantizer will be given to the symbol coder, and in symbol coder usually variable length coding is done, as discussed earlier also. What we are performing here, we are performing variable length coding, and for doing the variable length coding, we remove its coding redundancy, and we get the compressed image. This is how image compression is achieved in the transform coding. Excuse me. And now how do we decompress the image? For decompressing the image, first we pass the image to the symbol decoder. You can see we have passed the image to the symbol decoder. This is where the inverse of symbol decoder is working. So what it will do, it will give the value which is achieved from the quantizer. So this we will get here, and since we know there is no inverse law for quantizer, whatever data we will get or we chase during the quantizer, that cannot be retrieved back. So this is no block in the inverse process. So there is no block in the inverse process for the quantizer. So whatever data we will get here on that data, we will perform the inverse transformation. So inverse of Fourier transform will be inverse transform, and it will be done for all the sub images. And that for those sub images will merge to get the original n cross n image. N cross n decompressed image. This is how we perform compression and decompression in the transform coding. Hope this is clear to you. uh, Not discussing much about transform coding. Here we have some points which we have already discussed, or we have already cleared it. Still, I will just read it out for you. So, in transform coding, for most natural images, a significant number of the coefficients have small magnitudes and can be coarsely quantized or discarded entirely with little image distortion. So, as earlier discussed, we are getting some coefficients which are very small, and those small coefficients, just because of they are not coarsely or they are not being quantized, they are very small. So we just discard those coefficients, and we get the image with little image distortion. Now we have an n cross n input image. First is subdivided into sub images of size n cross n, which are then transformed to generate n by n square sub-image transform arrays, each of size n cross n. So when we were discussing the diagram, we discussed this thing also, that we are taking an image of dimension n cross n, and when we are subdividing, the dimensions changes to n cross small n cross n. So this is just to get the transformation for an input image of n divided by n square sub-image transform array. So now we have got the images for the size of n cross n. Now the goal of the transformation process is to decorrelate the pixels of each sub image, or to pack as much information as possible into the smallest number of transform coefficients. Now as we are decompressing the image, now we are just compressing the image. What we are doing is we are trying to find out the smallest number of transform coefficients. The quantization stage then selectively eliminates or more coarsely quantizes the coefficients that carry the less information. Since the quantizer process does not deal with the irreversible process, so what will quantization do? It will select some of the elements, some of the coefficients which are carrying the least information. Least information, if they are carrying the least information, they will just try to eliminate those coefficients. The encoding process terminates by coding, normally using a variable length coding the quantized coefficients. So the encoding process takes place, and it takes place by using the coding process. And in coding, what we use a variable length code. Any or all the transform encoding steps can be adapted to local image content, called adaptive transform coding, or fixed for all images called non-adaptive transform coding. So here we finishes with transform coding. So in next lecture we will be discussing about line detection and all. Till then, stay home, stay safe. Thank you.